This is a short, well, relatively short section showing a few bits and bobs printing. Hopefully in the introduction I will have shown you these parts. This is the crown wheel being printed for the differential. Some of the bits I've sliced up because they're pretty long. Some have been speeded up and some are at normal speed, and I can't remember which is which, but anyway, there we go. I'll just do a bit of an overdub on this and let you know what's happening. We're getting towards the end of the crown wheel here. Just finishing off the last little bits, and then it'll go on to printing the pinion. I should say that this section lasts exactly 8 minutes, so if you're not a fan of watching paint dry or plastic being printed, skip forward. That'll be about 6.5 minutes from now, and you'll get on to the rest of the video, what there is of it. Here's the pinion being printed. This is at normal speed, so you can see it's a pretty quick old printer. The squiggly lines on the right are the calibration process it can go through. It's optional. I started off using it, but I don't anymore. This was the second part to be printed on here, and I wasn't aware that there was a camera installed. I thought it was an optional extra, which I didn't have, but I've since found that I have got it, and to my surprise these sequences had been filmed on the SD card that I'd inserted. There we go. I'm coming up to the end. Oops, transition got a mixed up there, but we'll press on. I was amazed at the quality of the print that came off here, and the gears actually mesh quite well. This is the beginning of the handle being printed. If I haven't mentioned it in the introduction, I will go on to explain what the handle is all about. So this is part of the support tree for the end. It should become a bit clearer a little later on in the print, and it's now printing the first layer. This is actual speed. It now goes over and wipes its nose, and then the head comes up. You see the light come on. That is allegedly a laser beam, but I can't believe it's that. I would suspect it's more like an LED, and it's using what they like to call LiDAR to check the first layer for bed adhesion, accuracy, height and what have you. Then goes over to the home position, and if everything works out okay, it lays down the second layer, so on and so forth. Little bobbles there, but I think that's probably because the nozzle is got a bit of indigestion. Nearly halfway through this section now, and there we go, it's decided to speed up. and whizzy. It's infilling now, and that's the top or bottom layer, whichever way you hold the handle, I suppose. The infill going in. Does that for, I think, 2 layers, and then it does a more of a honeycomb, although not honeycomb because it's only a 4-sided rectilinear pattern for the infill to give a sort of sponge effect of the interior. There we are, you can see a bit better, and the support tree on the end is growing as well. It can cope with about 45 degrees of overhang before it actually needs any support, so that's quite useful. And as you can see, the layers build up quite quickly. Well, I say quite quickly, I think this probably took about an hour and a half to print, so not that quite quick. But compared with some, it's reasonably fast. There we are, we've got a bit of an upsweep there, with the support again growing. Since printing these, I've discovered that you have to make any holes, clearance holes for bolts and what have you, a little oversized because the holes are subject to a bit of shrinkage. So, for example, on a couple of pieces, the holes have to be 12 millimeters diameter to fit some silver steel rods in, and they turned out undersized, and I couldn't ream them out because I haven't got a reamer anymore, and using a drill was no good either. So the critical parts I've reprinted. This one I managed to get away with, just drilling out that hole there. You can see 6 millimeters. The slot was actually a little oversized, I think, anyway, so that's no problem. And coming up to the end now, just a few more agonising seconds, and that finishes off. Right, well, I'm back in the workshop after quite a lengthy break, really, since I received and unboxed the printer. I've had a few problems, not with the printer, I hasten to add, but with suppliers, and I've been waiting to get some material, which eventually arrived, or at least some of it arrived. The courier had managed to damage the parcel in the process of delivering it, and 2 of the 3 items were missing. So I'm still waiting for replacements. So that's delayed my latest project, which we'll come on to a little later. Anyway, you will have seen, hopefully, or you've probably skipped over the production of the crown wheel and pinion, which I seem to have mislaid. Oh, there it is. Quite a complex design, but nice finish. The only thing I can really complain about is the colour of the plastic, but there we are. That's what the printer came with, and so I'm too keen to get on with it to wait to further replacement stuff. However, being new to 3D printing, I hadn't realised that, although I should have done, I suppose, that any holes such as these in the this part here, In fact, any of the parts were all going to be printed undersize, and rather than having to wheel a heavy drill and drill them out by hand, I thought, well, I'll use a drill stand, forgetting of course that I've got rid of my mill and I don't possess a drill stand. So back to the drawing board, and what did I do? Well, I drew one up in CAD suitable, I hope, for printing. It's obviously going to be for light duty. I don't know whether that's going to come out very well with this lighting. No, it's not. I'll get another photo. I'll get another shot and cut it in. But hopefully I will have cut in a still of that design. And many hours later, there's the base printed out. Quite a nice finish. This is in fact the second one, because naturally enough the holes were undersized and I couldn't get the silver steel support rods in. They're still a bit tight, but I've printed them 0.2mm oversize, and I'm satisfied that I can press these together and they will come out quite nicely. This is what I'm waiting for, 2 more of these. This one arrived, it's a bit scratched but it's usable, and hopefully they'll arrive within the next couple of days and I can get on with building it up. I've still got some support material in here to get out. Can't see it, but this is the second one I've printed, because the first one obviously came out undersized on the holes, and it took about 7 hours to print this, which not bad I suppose considering the size of it. It's 250mm by overall 250mm, I think. So pretty sizable chunk of the old plastic. And the other bits I've actually pre-assembled them. That's the clamp for the rear of the device, the handle, which you may or may not have seen if you stuck with the printing sequence. That's there, and the motor mount. This is a 12 to 24 volt DC motor, which I bought for my I think it was for the die filer. Yes, I replaced that because it was too fast. I purchased a ER11. Again, the picture's not very good because of the sunlight coming through the window, but it's an ER11 collet with a 5mm hole to fit the 5mm shank. I'm going to be running this from a 12 volt supply, so that should cut the speed down somewhat. It can go up to 10,000 RPM at 24 volts, but I shan't be needing that hopefully. And it remains to be seen. When it came, of course, the 5mm in here in the collet wasn't 5mm. I had to drill it out, and had I had a reamer I would have done so and reamed it out, but I haven't got a reamer anymore, having given them away with the rest of the machine stuff that I got rid of. And all in all, I suppose this is the top of the drill stand. Obviously it goes up here, but that takes it out of shot. All in all, I think that was about an hour and 20 minutes. That, as I say, was about 4.5 to 5 hours. I increased the density of the infill to give it more strength, hopefully. I upped that to 25% from the standard or default 15%. so that took up a lot more time. However, I'm hopeful that the other silver steel rod will arrive fairly soon, and I can get on with constructing it. In the meantime, I'll have to get this support out. It's easy to do, just get a screwdriver behind it and it comes out with a single pull, he said, hopefully. There's a little bit of cleaning up to do, but not a lot. Anyway, that's about it for the catch up. I'll bring you back later on when I've got some more work done on it. Maybe even got it built up, who knows. Oh, before I go, I just, you may or may not be interested, I'm intending to build this differential up into a rear suspension to mock up a model of a race car, if you like. And to that end I've made some, I think you can see that, they're pretty tiny, some spherical joints. These are all printed with a 0.4mm nozzle, which is not really fine enough to do such small work. The bearing in the middle of that one doesn't work. This is a first iteration of one which has got a working bearing. Is that coming out? Oh no, there we go. Quite a bit of play in there. But hopefully I'm going to get a 0.2 nozzle. 0.2mm nozzle, that is. And print this out so that they're more accurate. And there we are. There we are. I can hardly see what I'm doing anyway. So that's I've forgotten actually how big these are, or should I say how small. And for scale, that's 11.7mm across there, and the bore of the bearing is should be 2mm, but obviously it's undersized. However, not to worry, we'll get around that. Several iterations of the print to get it more or less right. Just got a bit of a query on the new nozzle, which comes with complete hot end, because Bambu Lab crimp their nozzles into the hot end and don't screw them in like other manufacturers, and there's a discrepancy on the price of that on their website. So I've queried that, and once that's got sorted, then I'll have one on order, and we'll see how those bits come out in a later video probably. So that's just about it for now. A bit long and waffly, but there we go, that's one of those things. So if you have been, thanks for watching, and I'll catch you next time. Bye.